Okay, hello everybody. So given the map or the function, these are the same word, with formulas x equals some stuff with u's and v's and numbers, y equals stuff with u's, v's, and numbers, z equals stuff with u's, v's, and numbers. Explain how to convert these formulas to this notation and this notation, including labeling individual component functions f sub I, where this is an index variable. It's meant to be many different, like 1, 2, 3, 4, 5, however many we need. Okay. So I'll start with words in red. We need to know what are the inputs and the outputs. That's always what we have to identify first for the map. Okay, what are the inputs and outputs? So I look over here and I see x, y, z equals, and then always x, y, and z are in terms of the variables u and v. So the inputs are all the pairs u comma v, which are an element of R2. So these are the names. U and v are names for the input space, the input variables. Okay, and R2 is the input space. All possible inputs that we can plug in. Okay, and then the outputs then are this x, y, and z. So x, y, z is an element of R3, we're thinking, because these are the names of output variables. Okay. And so right away, I'm just going to jot down a picture in blue. So my input space will have two axes. One of them is the u-axis, the other is the v-axis. And then the output space will have 1, 2, 3 axes, and we label them in that order just so our pictures are always the same. The first, second, third, whatever they are, whatever order we listed them here, they should go here, here, here. Just because it'll make our pictures easier. And the picture doesn't matter which one goes where, so you could do it another way. But if you do it the same way every time, your mind will be free of those details and free to focus on the harder concepts that are coming in this class. So it's helpful to do it the same way every time. Okay, and so just to illustrate this, I mean, this is the input space. This is the output space. And so what happens here is we're mapping two-dimensional space into three-dimensional space. So the image of this map will be very thin. It'll be thin. So let's say we're going to map all the points in this blob here, which we'll call this two-dimensional blob. We'll call it the blob A. All these points. Point. And each point gets mapped over to some point in three-dimensional space. When we map the whole blob, maybe it looks like this. It's very thin. It's just like a thin sheet. And this is f of A. We write this f of A. F applied to A. If we just took a single point, like that point, if I labeled it 2, 2, then we'd say f of 2, 2 would be, maybe it's that point right there. I have no idea which point it is. This is just a cartoon, right? Okay. And let's see. So that's a good picture. So good we've got pictures there. Okay, now let's convert to this notation and this notation. So I'll go back to words for a moment. Because, well, now I'll switch to formula color. Formulas, maybe in this color. because of this, because x equals u squared v plus 2, then the first component function of f, by the way, this is an abbreviation for this long word function. You call it component function because, f maps all of R2 to R3, but that means it has to have 3 outputs. It needs 3 functions. And so the first one is called f1, and it maps from R2 to R, just namely the first output. It takes, and this should be actually in a formula color. f1 maps every input to just one number, one of the 3 outputs, the first, f1. Well, it takes uv and it sends it to u squared v plus 2. This is a number. This is just the first output. And then we can do the next one. f2 then will send uv to this formula. That's, you can't see it, it's cosine of u right there. 3 times u times v plus the cosine of u. Again, one number. And so it's just a single, it's one of these 3 outputs, but we need 3. And so here's the last one, u plus v minus 1. That's a minus 1. And so the third component function sends uv to u plus v minus 1. Okay? And maybe I'll fill this in because y equals 3 uv plus cos u, because z equals u plus v minus 1, because the second component function is the third component function is that. Okay, so we can sort of string this all together. Usually we put them together. So we take these 3 component functions and we put them together by writing, look, f is a map from R2 to R3. And so what does it do? It takes u comma v, because you see that all 3 of these component functions, they all have the inputs u, v. That's what we named them. And so we'll just string them together in something, something, something. And we put the first component function here, comma. Comma tells us now we're doing the next component function. It would tell the computer that there are 3 different things. The computer needs to know how many. And so we tell the computer with it by providing a separator. Like you might see CSV files, comma separated value. It's the same thing of how we tell a computer that this vector is a 3-dimensional vector. That there are really 3 formulas here, f1, f2, f3. And good. So let's see. This notation is sort of this top line, and then usually below it, we write this notation, which takes a particular input into a particular formula of the output. And so, these are the 2 notations. So that's, this is our answer. Okay. Great, we labeled the individual component functions. We show how they come together to give, down here, maybe I'll label this. This is the x maps to f of x. Where secretly x is u comma v, and f of x has 1, 2, 3 component functions. We could sort of write f1, f2, f3. There's a lot of things we can write. We can write whatever we want. We're free to make up all these symbols. But then over here, like this top notation is sort of hiding the complexity. It hides what, we don't care about the names if we don't care about the formulas for a moment, and we just want to think about what is the input space and what is the output space. Then this just tells us that F is some map taking 2 inputs to 3 outputs. Okay, good. If we want the full formula, then we put the actual formulas underneath, showing, like these are the 2 inputs, these are the 3 outputs. Okay, I was quizzing myself. Let's see how I did. Here's another way to answer this question. And roughly similar. You can pause and read this one.